May June 2024 पेपर टू वेरिएंट टू। ठीक है, मई जून 2024 पेपर टू वेरिएंट टू। इफ यू वांट टू टेक दिस पेपर आउट, जल्दी से निकाल लो ये पेपर। ठीक है, एंड लेट्स स्टार्ट विद द फर्स्ट क्वेश्चन। द लिस्ट बिलो shows some SI quantities perfect. Underline the quantity that is not an SI base quantity. Which quantity is not an SI base quantity? Okay. So if you remember, SI base quantities were seven quantities. उसके अलावा यहाँ पे कौन सी quantity लिखी हुई है? Charge. So charge is not the SI base quantity. वैसे तो हमने underline करना था. Why I am circling it? This is your not SI base quantity. Let's further move ahead. A square solar panel with sides of length of 1300 millimeter is shown in figure 1.1. Perfect. A light is incident normally on the solar panel. Perfect. Light is incident normally on the solar panel. The power of the incident, the power of the light incident on the solar panel is this. Perfect. Calculate the intensity of the light. You have to calculate the intensity of the light. Beta, do you remember the formula of intensity? इंटेंसिटी का फॉर्मूला क्या होता था? इंटेंसिटी यूज टू बी पावर ओवर एरिया. व्हाट इज पावर? 750. What, how will you calculate the area? Convert 1300 millimeter into meters. 1300 divided by what? 1000. 1.3 meters. Area will come out to be what? 1.3. 1.3. क्या आ जाएगा भाई आंसर? If I calculate this, this comes out to be 443. 443 volt meter minus 2. Okay, nothing complicated here. Let's further move ahead. Now, let's move on to the next one. Yeah, the percentage uncertainty in the incident power is this. Perfect. The percentage uncertainty in the length of each side is plus minus 5 millimeter. Perfect. You have to calculate the percentage uncertainty in the intensity of light. Okay. बेटा फर्स्ट ऑफ ऑल क्या करते हैं? डू यू रिमेम्बर फर्स्ट ऑफ ऑल हम क्या किया करते थे इनिशियली? और फर्स्ट ऑफ ऑल व्हाट डू वी यूज टू डू? वी कैलकुलेट द परसेंटेज अनसर्टेनिटी. कैलकुलेट करने के लिए सबसे पहला काम हम फॉर्मूला लिखते थे. सो इंटेंसिटी का फॉर्मूला इज व्हाट बेटा? पावर ओवर एरिया. परफेक्ट. सो इंटेंसिटी इज इक्वल्स टू पावर ओवर एरिया. Percentage uncertainty in intensity is equals to the percentage uncertainty in power. Percentage uncertainty in power plus the percentage uncertainty in area. Perfect. So how will we calculate the percentage uncertainty in power? Already given 3%. How will you calculate the percentage uncertainty in area? You know that area is equals to what beta? We have a square. Area is equals to length into length. Area is equals to length square. So you can calculate the percentage uncertainty of area as 2 times the absolute uncertainty of length divided by the length into 100. Do you have the absolute uncertainty of length? Yes, 5. Do you have the length? That is 1300. Yes. Divide, multiply by 100. Percentage uncertainty intensity is equal to 2 into 5 over 1300 into 100. 0, 0, 0, 0 cancel out. This becomes 10 over 13. That is roughly equal to 0.77. So the percentage uncertainty in intensity comes out to be 3 plus 0.77. That is 3.77 percentage. Simple as that. Literally nothing complicated here. बात समझ आई बेटा? Any ambiguities here? पूछ लो कोई भी ambiguity. The useful power output of the solar panel is this. Perfect. This is the power output. Perfect. Calculate the percentage efficiency of the solar panel. You have to calculate the percentage efficiency. What is the formula of percentage efficiency? What is the formula of percentage efficiency? Power output divided by power input into 100 into 100. Power output given है बेटा 160. Yes. Power input निकाली है हमने कहीं. हाँ, we are given power input as well. डिवाइड कर दो दोनों को, मल्टीप्लाइड बाय 100. Power output is 160, power input is 750 multiplied by 100. क्या आंसर आएगा भाई? Any geniuses in the chat that can calculate this? Percentage efficiency comes out to be 21%. चलो देख लेना, no problem. Another square solar panel is placed so that the light of the same intensity is incident normally on it. The new panel has shorter sides than the original panel. The new panel has the same power output as the original panel. Perfect. State and explain whether the efficiency of the new panel is greater, less than, or the same as the efficiency of the original panel. Perfect. So, new panel has shorter sides. If your new panel has shorter sides, what will that do? The new panel, the new panel will have a lesser area. Simple. If your area becomes less, what will happen? If you go here beta, अगर आपका area less हो जाए, so what will happen? Intensity is equals to power over area. Perfect. Area is becoming less. And can you see the new panel has the same power output? Perfect. And the same intensity. Perfect. So just help me out a bit. Let's say मैं area को left side पे ले जाता हूँ. Intensity into area is equals to power. Now if the intensity is same, can I say power is directly proportional to area? If area decreases, your input power will decrease. If area decreases, your input power decreases. Simple. This P is your input power. Let me bring this calculation in the same part so that you don't get confused when you see the annotated past papers. 1 second. हाँ, ये आ गया. So we know intensity is equal to power over area. We take area to the left side. Intensity is constant. We replace it with a direct proportionality sign. Power is directly proportional to area. As area decreases, power input decreases. So you will say the new panel will have a lesser area. Hence, a lower input power. Lower input power. If your power input is lower, what will happen? If your power input is lower, what will happen? Efficiency is equals to what? Power output over power input. If power input becomes less, efficiency becomes greater. You can write this. Hence, a lower power input. This results. This this causes would be a better English word. This causes the overall efficiency to increase. Simple. Okay. All clear? Is the question one clear to all of you? कोई भी ambiguity यहाँ पे you can ask. Yes. Any ambiguities you can ask. Clear है? आगे बढ़े. चलो let's switch them over. Let's see this. A skydiver jumps from an aircraft at time t is equals to 0 and fall vertically downwards. Perfect. The variation with time t of her velocity is shown in figure 2.1. Now, as I have told you, बेटा जब भी आपने एस लेवल फिजिक्स में, ओ लेवल फिजिक्स में, A2 लेवल फिजिक्स में भी इंशाल्लाह जाओगे, तो वेन एवर यू सी अ क्वेश्चन, कुछ चीजें खुद से आइडेंटिफाई किया करो, तो थोड़ा सा कॉन्फिडेंस बढ़ जाता है. इफ आई सी दिस क्वेश्चन एंड जस्ट सीइंग द ग्राफ, आई कैन टेल कि दिस हिस्सा इज गेटिंग कांस्टेंट वेलोसिटी. And if an aircraft or a skydiver is falling from an aircraft, falls vertically downward, and he reaches a constant velocity, that velocity will be known as terminal velocity. I literally don't know whether this will be used in the question ahead or not. बट अगर ये क्वेश्चन में यूज होता है सोचो कितना कॉन्फिडेंस बूस्ट हो जाएगा एंड एग्जामिनेशन इट्स ऑल अबाउट कॉन्फिडेंस सारी कॉन्फिडेंस की गेम होती है थ्योरी सबको आती होती है देखो क्या लिखा हुआ यूज फिगर 2.1 टू स्टेट द टर्मिनल वेलोसिटी ऑफ द स्काई डाइवर सो व्हाट इज द टर्मिनल वेलोसिटी ऑफ द स्काई डाइवर वेरी वेरी इजी दिस 39 सिंपल जस्ट एज अगर कोई लाइफ में अनएक्सपेक्टेड डिफिकल्टी आ जाती है तो तुम लोग घबरा जाते हो उसी तरह इफ यू मार्क समथिंग एंड देन द एग्जामिनर आस्क द सेम थिंग तो यू गेट अ वेरी कॉन्फिडेंट ठीक है अब देखो आगे क्या लिखा है by drawing a suitable line on figure 2.1 determine the acceleration of the skydiver at time t is equals to 9 seconds perfect we are given the velocity versus time graph and the gradient of velocity time graph is equals to acceleration we have to calculate the acceleration at 9 seconds. That is at this point. So, how will you calculate the gradient at this point? Please realize that this is a curve. To calculate the gradient of curve, what is the number one step? Draw a tangent. The number one step to calculate the gradient is to draw a tangent. Let's draw a tangent like this. Now, obviously, since I am working this out on a digital thing, तो ये इसका gradient थोड़ा सा ऊपर नीचे हो सकता है, but I will try my best. चलो, you have this tangent, draw a tangent. Second point will be to select 2 points. Now select 2 points of your own choice. Now here I will select this point, which looks pretty fine to me. This one. This is what? 4.5 and 30. Any other point? You can also take the point of the tangent, but I don't want to take that. And this is also good. This is x axis पे क्या है बेटा ये? This is x axis पे 15.5. 15.5 and y axis पे it is 43. Can you calculate the gradient here? Very easy. Gradient is equals to y2 43 minus 30 over x2 that is 15.5 minus x1 that is 4.5. Can you calculate this 13 divided by 15.5 minus 4.5 11. Perfect. 13 over 11. What is your answer? This comes out to be 1.2 ms minus 2. 1.2 ms minus 2 or 1 point you can say 1.8. Let's write it 1.18. 1.18 ms minus 2 is your acceleration. Simple. And let's write it down 1.18 ms minus 2. Simple. Let's further move ahead. The mass of the skydiver and her equipment is 68 kg. The upthrust on the skydiver is negligible. Perfect. After reaching terminal velocity, the skydiver opens her parachute at time t is equals to t1. A total drag force of 1800 Newton acts on the skydiver. Calculate the magnitude and the acceleration of the skydiver at time t is equals to t1. So let's suppose this is your skydiver. This little object is your skydiver, and the drag force, an upward drag force of 1800 Newton is acting like this. Beta downward force कौन सी होगी? The downward force will be the weight. How can you calculate the weight? Are you given the mass? Yes, 68. So weight will be equal to what? Mass into gravitational field distance. 68 into 9.81. Can we calculate this? 68 into 9.81. This comes out to be 667. 667. Now, can you guys calculate the resultant force? Can you guys calculate the resultant force beta here? Yes, 1800 minus 667. What does this comes out to be? This comes out to be 1133 newtons. Perfect. You have to calculate acceleration and the direction of it. So what will we do? Resultant force is equals to ma. 1133 is equals to mass, that is 68, into acceleration. 1133 divided by 68 is equals to your acceleration. Divided by 68, this comes out to be 16.6 is your acceleration. Ms minus 2 is your acceleration. And what will be your direction of acceleration? Always remember that the direction of acceleration is the same in which the greater force is being applied. The direction of acceleration is the same as the direction in which the greater force is being applied. The greater force is being applied upward, so the direction of acceleration is upward like this. Like this. Simple. Perfect. Let's further move ahead. The parachute is fully open at time t is equals to 2. At a time t3, the skydiver reaches a constant velocity of 5.7. ठीक है. Described and explain the variation with time t of the magnitude of her acceleration between time t is equals to 2 and time t is equals to t3. देखो अब एग्जामिनर क्या कह रहा है, सिंपल सी बात समझो, नो नीड टू कॉम्प्लिकेटेड. एग्जामिनर कह रहा है कि एट टाइम t इज इक्वल्स टू t3, जब टाइम t इज इक्वल्स टू t3 हो रहा है तो यू आर अगेन रीचिंग अ कांस्टेंट वेलोसिटी. What is happening to the acceleration का magnitude of the skydiver as he travels from time t is equals to 2t till time t is equals to 3t. So, and you have to explain it as well. Hmm. So, what will you say? If you can see, if you can see बेटा, अगर आपकी upward force ज़्यादा है, downward force कम है, what will happen? Your velocity will decrease. योर वेलोसिटी विल डिक्रीज या स्पीड डिक्रीज. देखो बेटा, अगर आपकी अपवर्ड फोर्स ज्यादा है, डाउनवर्ड फोर्स कम है, दिस विल कॉज व्हाट? दिस विल कॉज योर स्पीड टू डिक्रीज. ये उसी तरह है जब आप गाड़ी में ब्रेक लगाते हो. योर बैकवर्ड फोर्स इज ग्रेटर देन द फॉरवर्ड फोर्स, हेंस योर स्पीड डिक्रीजेस. एंड इफ यू रिमेंबर बिल्कुल बेसिक क्लासेस, यू माइट हैव नोन कि मैंने एक की पॉइंट बताया था, छोटू सा एक की पॉइंट लिखवाया था यहाँ पे, कि drag force is directly proportional to velocity. Air resistance is directly proportional to velocity. So you will say as speed decreases, as speed decreases, drag force, drag force decreases. Okay. Now, when you are reaching a constant velocity, what will happen? When you are reaching a constant velocity, what will happen? Drag force will decrease so much that it will equal to 667 Newton. That is the weight. When you are reaching a constant velocity, the drag force will decrease so much that the upward force of drag force will equal to the downward weight. Simple. Both will be equal to the 66 Newton. Let's write it down. As the speed decreases, drag force decreases at a point, or you can say at time t3, the drag force equals what? Equals the weight. Equals the weight. The resultant force becomes 0. Hence, acceleration becomes 0. Hence, acceleration becomes 0. Simple. Calculate the change in momentum of the skydiver between time t is equals to t1 and time t is equals to t3. You have to calculate the change in momentum of the skydiver between time t is equals to t1 and time t is equals to t3. What is change in momentum? What is change in momentum? Very, very easy. इसको क्या हो गया वापस? Okay. So what is change in momentum? Change in momentum is equals to mass into change in velocity. Simple as that. Change in momentum is equals to what? Mass into change in velocity. Perfect. Change in momentum is equals to mass into change in velocity. What is the mass of the skydiver? 68 kgs. Perfect. What will be your change in velocity? What is the final velocity? Final velocity is 5.7. At time t is equals to 3, your velocity is 5.7. At time t is equals to 1, what was your velocity? At time t is equals to 1. Where is time t is equals to 1? Okay. Okay. After reaching terminal velocity, the skydiver opens the parachute at time t1. So at time t1, you will have a velocity of 39. Perfect. So 5.7 minus 39. What does your change in momentum comes out to be? Yes, your change in momentum comes out to be negative 2300 Newton second. Simple as that, nothing complicated here. All clear beta, आगे बढ़े, yes or no? Lightning occurs when charge builds up in the atmosphere, creating a potential difference between the ground and the atmosphere. During a lightning strike, there is an average current of this for a time of this. Calculate the charge transferred. बेटा हमने क्या पढ़ा है? करंट इज इक्वल्स टू चार्ज ओवर टाइम. परफेक्ट. करंट की वैल्यू क्या है? 3.3 into 10 is the power of 4. What is the value of time? 2.6 into 10 is the power of minus 5. Can you calculate the charge? Can you calculate the charge here? Yes. The charge comes out to be what? 0.86 coulombs. 0.86 coulombs. Simple as that. The potential difference between the ground and the atmosphere is this. Calculate the average power in gigawatts during the lightning strike. So power is equals to IV. Current क्या था बेटा? 3.3 into 10 raised to the power of 4. What is the voltage? 3 into 10 raised to the power of 7. Can you calculate the answer? 3.3 into 3. This comes out to be 9.9. 9.9 into 10 raised to the power of 11 volts. But you have to calculate in terms of gigawatts. Now, what is the power of giga? Giga is 10 raised to the power of 9. So, what can you do? You can take this decimal one place, two place forward. This comes out to be 990 gigawatts. 990 gigawatts is your answer. Nothing complicated here. Let's further move ahead. आगे देखते हैं क्या लिखा हुआ है भाई. A lightning rod is attached to a tall building to conduct charge safely to the ground. The lightning rod is modeled as a uniform cylindrical copper cable of total length this that turns from the ground to the top of the building as shown in figure 3.1. Perfect. The resistivity of the lightning rod is this. Sorry, resistance of the lightning rod is this. The resistivity of copper is this. You have to calculate the radius of the lightning rod. Very, very easy. Have we studied this formula? Resistance is equals to resistivity L over A. What is resistance? 9.6. Perfect. What is resistivity? 1.7 into 10 is the power of minus 8. What is length? Length is 95 meters. So, beta, can I make area the subject here? Yes, area is equals to resistivity, that is 1.7710 is the power of minus 8 multiplied by length, that is 95. Perfect. Divided by the resistance, that is 9.6. What does your area key value come out to be? The area comes out to be 1.7 into 10 is the power of minus 8 into 95 divided by 9.6. This comes out to be what? 1.68 into 10 raised to the power of minus 7 meters square. This is your area, but you have to calculate the radius. So in place of area, you will place pi r square 1.68 into 10 raised to the power of minus 7. R is equals to what? Under root 1.68 into 10 raised to the power of minus 7 over pi. Can you calculate this answer? Yeah, very easy. This comes out to be 2.3 into 10 raised to the power of minus 4. 2.3 into 10 raised to the power of minus 4 meters. Simple as that, nothing complicated. The radius of the lightning rod is doubled with no change to its length. Perfect. State the effect of this change on the resistance of the lightning rod. Perfect. So if you double the radius, your radius goes from R2 to R. What will happen to area? What will happen to area? We have studied that area is equals to what? Pi R square. Area is directly proportional to radius curve square. If your radius goes from R2 to R, your area will go from A to 4A. And we have studied that resistance capital R is inversely proportional to area. If your area becomes 4 times, your resistance will decrease by 4 times. It will become 1 over 4R. It will become 1 over 4R. You can say resistance. You can say resistance decreases by a factor of 4. Simple as that. You can say that resistance decreases by a factor of 4. Simple. अब आगे बढ़ते हैं भाई. A section of the lightning rod of length 0.12 meter is removed for testing. Okay, so your length is 0.12 meters. A tensile stress of this is applied. This is your stress. Perfect. As shown in figure 3.2. Perfect. The section of the rod obeys Hooke's law. The Young's modulus is this. You have to calculate the extension of the wire. You have to calculate the extension of the wire. So how can you do that? Very, very, very easy. You know that Young's modulus is equals to what? Stress over strain. Perfect. Young's modulus is equals to what? Stress over strain को आप किस तरह लिख सकते हो? Extension over the total length. Perfect. Now, can you rearrange this? Young's modulus is equals to stress into length over extension. Perfect. Can you make extension the subject here? Yes, extension is equals to stress into length over the Young's modulus. What is the stress, beta? What is the stress? Can you tell me? The stress is 1.9 into 10 raised to the power of 6. 1.9 into 10 raised to the power of 6. Length क्या है भाई? Length is 0.12 meters. Perfect. Length is 0.12 meters. What is the Young's modulus? 1.3 into 10 raised to the power of 11. What does your extension comes out to be? बेटा extension क्या आ जाती है? Calculate करो. Extension comes out to be 1.8 into 10 raised to the power of minus 6 meters. Any questions in this entire question में कोई confusions है बेटा? Simple plus minus की भी confusion है तो पूछ लो. No problem in that. Clear है तो भी बता दो. क्लियर है. चलो अल्हम्दुलिल्लाह भाई आगे बढ़ते. Now let's see. ये वाली चीज देखते. A pinball machine uses a spring to launch a small metal ball of mass. This upper ramp, the spring is compressed by this and held in equilibrium as shown. Perfect. The ramp is at an angle of 15 degree to the horizontal. The spring obeys Hooke's law and has a spring constant of this. Calculate the elastic potential energy in the spring. Okay, we have to calculate the elastic potential energy in the spring. Do we have the compression? Yeah. Do we have the spring constant? Yes. Can you calculate the elastic potential energy? Very, very easy. Elastic potential energy is equals to what? 1 over 2 K E square. What is K? 29. Perfect. What is extension or you can say compression? 8 into 10 is the power of minus 2. 8 into 10 is the power of minus 2 whole square. What does your elastic potential energy comes out to be? What does your elastic potential energy comes out to be? Any idea? 9.3 into 10 is the power of minus 2. 9.3 into 10 is the power of minus 2 joules is your elastic potential energy. The spring is released and expands quickly back up to its original length. Perfect. Calculate the increase in gravitational potential energy of the ball when the spring returns to its original length. Perfect. So, beta, if the spring returns to its original length, the ball is traveling 8 into 10 raised to the power of minus 2 in the, you can say, diagonal direction. This is the distance that the ball is traveling in the diagonal direction. But this is not the height. This is not the height. What will the height be? What will the increase in height of the ball be? This blue line. How can you calculate this height? This is 15 degrees. This is the hypotenuse. Can you calculate the height? Yes. Sine of 15 is equals to perpendicular, that is height, divided by the hypotenuse, that is 8 into 10 is the power of minus 2. 8 into 10 is the power of minus 2. Sine of 15 is equals to your perpendicular height. Now, can you calculate the increase in gravitational potential energy? Yes. mg into change in height. What is the mass of the ball? Mass of the ball is 4.5 into 10 is the power of minus 2. 4.5 into 10 is the power of minus 2. Gravitational field strength is 9.81. Change in height is what? Change in height is 8 into 10 is the power of minus 2. 8 into 10 is the power of minus 2 into sine of 15. Can you calculate the increase in gravitational potential energy? Yes. 9.1 into 10 is the power of minus 3. 9.1 into 10 is the power of minus 3 joules is your increase in gravitational potential energy. बेटा is this part clear to you? ये थोड़ा सा difficult part था. Is this part clear to you? The ball leaves the spring when the spring reaches its original length. Assume that all the elastic potential energy of the spring is transferred to the ball. Calculate the speed of the ball as it leaves the spring. Perfect. तो बेटा सारी की सारी इलास्टिक पोटेंशियल एनर्जी ऑफ द स्प्रिंग इज ट्रांसफर्ड टू द बॉल. Perfect. So the elastic potential energy of the spring is transferred to the ball. Now ball has two types of energies. Now ball has two types of energies. As you have just seen, there is an increase in gravitational potential energy of the ball as well. And there will be some amount of kinetic energy in the ball as well. 9.3 into 10 is the power of minus 2. Perfect. And the ball has a gravitational potential energy and kinetic energy. We have already calculated. अच्छा V तुमने पहले ही निकाल लिए भाई वाह. Yeah, that's correct भाई. माशाल्लाह माशाल्लाह माशाल्लाह. Very good improvement भाई. Very good. So 9.3 into 10 raised to the power of minus 2 है minus 3 है. Let me see. Minus 2 है. Sorry, my bad. This is minus 2 joules of energy for elastic potential energy. What is the gravitational potential energy? 9.1 into 10 is the power of minus 3. 9.1 into 10 is the power of minus 3. Plus half into what is the mass of the ball? The mass of the ball was 4.5 into 10 is the power of minus 2. 4.5 into 10 is the power of minus 2 into velocity square. Can you calculate the velocity of the ball? Yes, can you calculate the velocity of the ball? Yes, very easy. Velocity, as you have told me, beta, it comes out to be 1.93 ms minus 1. We round it off till three significant figures. Chalo. And let's further move ahead. The ball comes to a rest on a tripod door, on a trap door of negligible mass at a distance of d from its pivot. Perfect. Force acts vertically downwards at a distance of 2 centimeters from the pivot as shown in figure 4.2. Perfect. The trapdoor is in equilibrium when F is 1.7 Newton. Calculate the value of D. Perfect. We have to calculate the value of D. We know that the trapdoor is in equilibrium if F is 1.7 Newton. Beta, if your trapdoor is in equilibrium, that means what? Anti-clockwise moment is equals to clockwise moment. The ball has a mass which will exert a weight downward 4.5 into 10 raised to the power of minus 2, and your gravitational field strength is what? 9.8. So multiply it. What does this 9.81, sorry, what does this weight comes out to be? 4.5 into 10 raised to the power of minus 2 into 9.81. Perfect. This is 0.441. This is 0.441 newtons. This weight will cause the trap door to move in which direction? Clockwise direction. What is the clockwise moment? 0.441 into the distance, that is d. What will be the anti-clockwise moment? What will be the anti-clockwise moment? Force into the distance, that is 2 centimeters. Perfect. Can you equate both of them? Yes. 0.44 d is equals to 2f. And f is what? 1.7. Perfect. D is equals to what? 2 into 1.7 divided by 0.441. So 2 into 1.7 divided by answer 7.7 centimeter is your D. Now, if you write 7.7 centimeter, you will probably not getting a marks. If you write 7.7 centimeter, you will probably not get a marks. Why? Because you have to give your final answer in terms of meters. Beta final answer आपने in terms of meters देना है. So what will you say? This will be divided by 100, 0.077 meters. Simple as that. Nothing complicated here. Let's further move ahead. Let's see the next part. क्या लिखा हुआ है? Force F is decreased from 1.7 newtons. Perfect. So this force is decreased from 1.7 newton. Let's say this has now become 1.5 newtons. Okay, let's say this has now become 1.5 newton. State the direction of the resultant moment about the pivot on the trapdoor. Okay, so if the force is decreased, if this force F is decreased, what will happen? Anti-clockwise moments will reduce. As the anti-clockwise moments reduce, the trapdoor will shift in the clockwise direction. The resultant moment will be in which direction? Clockwise direction. Any confusions, any ambiguities here बेटा? इस पूरे सवाल में कोई मसला मुझे पूछ लो. स्टेट किरचॉफ सेकंड लॉ भाई. किरचॉफ सेकंड लॉ क्या होता है? वी हैव टू स्टेट दैट. What is Kirchhoff's second law? Kirchhoff's second law basically says sum of electromotive forces is equal to sum of potential difference around a closed loop. So you can write it down. Kirchhoff's second law states that potential differences, sum of potential differences is equals to what? Is equals to the sum of electromotive force around a closed loop. Simple. Let's further move ahead. अब आगे बढ़ते हैं. एक सेकेंड. चलो, let's start भाई. Let's start. First of all, we have to define what is Kirchhoff's second law. Kirchhoff's second law बेटा क्या कहता है? Kirchhoff's second law basically states that the sum of electromotive force is equal to the sum of potential differences around a closed loop. Simple as that. कुछ ज़्यादा इसमें जो है वो rocket science नहीं है. Let's further move ahead. आगे बढ़ते हैं भाई. Now, let's see this. A battery of electromotive force 9 volts and negligible internal resistance, okay, is connected in series with a variable resistor X and a thermistor Y as shown in figure 5. ठीक है. एक बैटरी है 9 वोल्ट्स की. इट इज कनेक्टेड विद अ वेरिएबल रेजिस्टर एंड अ थर्मिस्टर. परफेक्ट. फिगर 5.2 shows the relationship between the temperature and the resistance of the thermistor. Okay. So this graph is given that is between temperature and resistance of the thermistor. Okay. The current in the circuit is this. The current in the circuit is 1.1 into 10 raised to the power of minus 2 ampere. The potential difference across Y is 4 volts. Calculate the resistance of X. Okay, okay, okay. So if you notice, the current in the circuit is what? Current in the circuit is 1.1 into 10 raised to the power of minus 4 ampere. Since it is a series circuit, beta current की value will remain this throughout. Sorry, it is minus 2. 1.1 into 10 raised to the power of minus 2 ampere. The current in the circuit is 1.1 into 10 raised to the power of minus 2 ampere. Simple. Okay. And the voltage across Y is what? 4 volts. Perfect. So the voltage across Y is 4 volts. What will be the voltage across X? What will be the voltage across X? Yes. What will be the voltage across X? 9 minus 4 is equals to 5 volts. Simple as that. So across X, you have a voltage of 5. You have a current of 1.1 into 10 raised to the power of minus 2. Can you calculate the resistance of X? Yes, resistance of X is equals to voltage across X divided by the current across X. What is the voltage across X? 5. What is the current? 1.1 into 10 raised to the power of minus 2. Can you calculate what will be the resistance across X, or what will be the resistance of X? The resistance of X comes out to be 450 ohms. Simple as that, nothing complicated here. Let's further move ahead. Also, let me put in this working here. Let's put this working here. Yeah, let's place this working here. Hey, resistance of X. What do we know? What is the resistance of X? 450 ohm. Perfect. Now let's further move ahead. I don't know why this has shifted here. Okay. The temperature of Y is 190 degrees centigrade. The resistance of X remains unchanged. So that means it is 450 ohms. Perfect. Determine the new potential difference across Y. Okay, you have to determine the new potential difference across Y. So if the temperature of Y is 190 degrees centigrade, if the temperature of Y is 190 degrees centigrade, can you calculate the resistance of Y? Yes. At a temperature of 190, the resistance will be what? 25 ohms. At a temperature of 190, can you realize that the resistance will be 25 ohms? Perfect. So this thermistor now has a resistance of 25 ohm. X has a resistance of 450 ohms. Can you calculate the current across the circuit? Can you calculate the new current across the circuit? And if you are a little smart, you wouldn't even need to calculate the current across the circuit. If you are a little smart, you wouldn't even need to calculate the current across the circuit. What will you do? You will apply the voltage divider rule. You will apply the voltage divider rule. I have to discuss this rule in the previous classes as well. Let's discuss it again. If you have a battery, let's say this is of 9 volts, and you want to calculate how much of this 9 volts will be provided to 450 ohms and how much will be provided to 25 ohms, you will apply this simple rule. Resistance of the component divided by the total resistance multiplied by the total voltage is equals to your voltage across the component. What is the resistance of component Y? 25. What is the total resistance? 450 plus 25, that is 475. What is the total voltage? 9. What will be the voltage across thermistor Y? Calculated. This becomes 1. This becomes what? 25 divided by 475. This comes out to be 19. And 9 divided by 19. This gives you a value of 0.47. 0.47 volts is the voltage across thermistor Y. Simple, nothing complicated. समझ आई बेटा ये बात? Let's take this thing to the downside. इसको हम यहाँ पे लेसन कर देते हैं सिंपल. चलो let's see. The resistance of R is increased. Okay. So the resistance of R, that is the variable resistor, is now increased. The temperature of Y remains at 90 degrees centigrade. By reference to the current in the circuit, state and explain the effect of this change, if any, on the potential difference across Y. So what is happening? The resistance of thermistor is remaining same. However, you are increasing the resistance of the variable resistor, that is X. If you increase the resistance of the variable resistor, what will happen? बेटा अगर आप वेरिएबल रेजिस्टर की रेजिस्टेंस इंक्रीज करते हो व्हाट विल हैपन द टोटल रेजिस्टेंस ऑफ द सर्किट इंक्रीजेस द करंट decreases as the current decreases what will be the voltage across the thermistor Y current into the resistance remains constant but if your current decreases across the thermistor your voltage will decrease. Now sir, how to write this? How to write this as a three marker question? First of all, you will say, first of all, you will say, as resistance increases, or you can say as resistance of variable resistor, as resistance of X increases, the total resistance increases. Perfect. This causes the current in the circuit to decrease. This causes the current in the circuit to decrease. Perfect. What will be your last statement? The current, as the current across thermistor Y decreases, the voltage across Y decreases. Simple as that. Now, beta, tell me if you have any ambiguities in this question. Top to bottom, koi masla, Muiz, koi masla, Nemil, koi masla, beta. Anything that you guys find difficult here, बताओ मुझे. We can discuss it again. कोई भी ऐसी small little चीज हो जो नहीं समझ आ रही हो इधर, you can ask right away. Hmm. कोई ऐसी चीज जो ना समझ आ रही हो. Light of a single frequency is incident normally on a diffraction grating. Perfect. Beta, light is incident normally on a diffraction grating. An interference pattern of bright and dark fringes. An interference pattern of bright and dark fringes forms on the semicircular screen. Okay. So an interference pattern forms on this screen. Perfect. Light has wavelength of this. The separation of lines in the grating space is this. So basically, this is what? This is your lambda. This is your D. Determine the total number of bright fringes formed on the screen. Perfect. We have to determine the total number of bright fringes formed on the screen. How will you do that, beta? How will you do that? First of all, you will say, to calculate the maximum order. To calculate the maximum order, do you remember क्या करते थे हम? To calculate the maximum order, n lambda over d should be less than 1. What is lambda? 5, 20 into 10 raised to the power of minus 9. divided by d, that is 3.8 into 10 raised to the power of minus 6, must be less than 1. Perfect, let's calculate that. 520 into 10 raised to the power of minus 9 divided by 3.8 into 10 raised to the power of minus 6. Perfect. 1 divided by answer. Okay. Your n should be less than 7.3. Your n should be less than 7.3. So what will be your maximum order? What will be your maximum order? Your maximum order will be 7. I don't know what does this term of 7 mean. ये 7 की term क्या मतलब बता रही है हमें? This means that let's say this is the central bright fringe. Let's say this is the central bright fringe. Then you will have the first bright fringe, second bright fringe, third bright fringe, fourth bright fringe, fifth bright fringe, sixth bright fringe, and seventh bright fringe. Central bright fringe के अलावा you will have 7 other bright fringes. So you will say, sir, this is 1, this is 7. The total answer should be 8. But you have conveniently ignored that if there are 7 bright fringes on the top, there will be 7 bright fringes on the bottom as well. If there are 7 bright fringes on the top, there will be 7 bright fringes on the bottom as well. What is the total number of bright fringes? 7 on the top plus 7 on the bottom plus 1 central bright fringe. 15 comes out to be your answer. Here you must remember that whenever you have to calculate the maximum order, you will apply this formula. बेटा जब भी यंग्स डबल स्लिट एक्सपेरिमेंट में यू हैव टू कैलकुलेट द मैक्सिमम नंबर ऑफ ब्राइट फ्रिंजेस और मैक्सिमम ऑर्डर यू विल अप्लाई दिस फॉर्मूला. ऑल क्लियर? एनी एम्बिग्विटीज? एनी चैलेंजेस हियर? ये सवाल ऐसा था जिसमें लास्ट ईयर बहुत सारे स्टूडेंट्स ने गड़बड़ की थी. ए स्टूडेंट्स, ए स्टार स्टूडेंट्स, ऑल ऑफ देम फंबल्ड दिस वन. बेसिकली ये वेरिएंट जो है वो पाकिस्तान वाला वेरिएंट है. देखो 2022 many of my students fumbled this question, तो ये एक दफ़ा ध्यान से देख लो. If you have any questions here you can ask again. This comes out to be 15. 15 is your answer. Okay, chalo, let's move ahead. The light is replaced with red light of a single frequency. Perfect. So now your light is replaced with red light of a single frequency. बेटा अभी आपकी वेवलेंथ क्या है? 520 nanometers. If you replace it with a red light, what will happen? The wavelength will increase. Why? Because the wavelength of red light is close to 700 nanometers. Beta, red light की wavelength is close to, yes. Less than 1 is part of the equation. Yes. देखो, good. इस तरह क्वेश्चन पूछा करो. सी यू हैव टू आस्क क्वेश्चन, वरना तो फिर यू वुडंट लर्न एनीथिंग. डिफ्रैक्शन ग्रेटिंग का फॉर्मूला क्या होता था बेटा? डी साइन थीटा इज इक्वल टू एन लैम्डा. दिस इज द जर्नल फॉर्मूला. This is the journal formula of diffraction grating. This is the journal formula of diffraction grating. However, if you want to calculate the maximum orders, इस formula को थोड़ा सा हम shift करते हैं. D comes in the denominator and we say this must be less than 1. ठीक है? तो ये दो formulas होते हैं for diffraction grating. चलो. Now we know if you are replacing the light with a red light, what will happen? Lambda will increase. Perfect. Let's see. State whether the frequency of red light is greater than, less than, or the same of the frequency of the original light. What will happen to the frequency? The frequency will obviously be less. The frequency will obviously be less. Less than the original light. Simple. Chalo, let's further move ahead. State and explain the effect of this change on the number of bright fringes formed on the screen. A calculation is not required. Perfect. Now, how will this frequency ka decrease will affect the number of bright fringes on the screen. Now, if you write that formula again, n lambda over d must be less than 1. Okay. If your lambda increases, if your wavelength increases, what will happen, beta? If your wavelength, अच्छा let me do one more thing. चलो एक और चीज कर लेता हूँ तो आपको और आसानी हो जाएगी यहाँ पे. Let's do one thing. Let's take d to the other side and lambda in the denominator. If your lambda increases, रेड लाइट का लैंडा ज्यादा होता है ना, तो लेट्स से योर लैंडा increases, what will happen to your maximum number of orders? Maximum number of orders decreases. If your maximum number of orders decreases, what will happen? Total number of bright fringes will be less. If your maximum number of orders decreases, beta, total number of orders भी क्या कर जाएंगे? Decrease. Let's write this down. Let's write this down. क्या लिखोगे? You will say as wavelength of a red light is greater, the maximum number of orders will be less. And if the maximum number of orders will be less, what will happen? Hence, the total number of orders will be a total number of bright fringes. Total number of bright fringes will be less. Total number of bright fringes will be less. And also, you might be wondering, sir, ये order क्या है? Maximum number of order क्या है? This is just maximum number of bright fringes on one side. This is just maximum number of bright fringes on one side, top or bottom. Is this entire question clear? Should we move forward? Yes or no? Is this entire question clear? देखो अब क्या लिखा हुआ है. A particle Q and a particle R are each composed of one quark and one antiquark. Perfect. State the name of the class of group of particles that includes Q and R. Which particles or which type of particles include only two quarks? Beta, if your object is made of only two quarks, that is known as hadron. If your object is made of only two quarks, that is known as hadrons. कोई भी object अगर two quarks से बना हुआ है, that is known as hadron. Simple as that, nothing complicated. Q has a charge of negative 1e, E is the elementary charge, and R has a charge of 0. Perfect. Complete table 7.1 to show a possible second quark in each of Q and R. Perfect. So if you have a strange quark as the first quark in Q, what will be the second quark in Q? You can say it can be what? It can be anti-charm quark. Now, how do you know that, sir? How do you know that, sir? I have just memorized the cork charges. Let me show you from the notes, भाई. Notes दिखा देते हैं हम लोग को. Second. Yeah. So if you remember, where did I wrote it? One second. Now, if you remember, your strange cork has a charge of what? Negative 1 over 3. But we want what? But we want a charge of negative E. But we want a charge of negative E. तो बेटा हम कौन सा चार्ज यहाँ पे प्लस कर सकते हैं? We can add an anti-up cork, we can add an anti-charm cork, or we can add an anti-torque cork. Any one of them will suffice your needs. Okay, let's wait this see. Now, you have an anti-up cork. Now, what is the charge of anti-up cork? Negative 2 over 3. You have to make an overall charge of 0. You have to make an overall charge of 0. What can you say here? Which charge will you use here? Maybe an up cork. Maybe an up cork. Because up cork का charge क्या होगा बेटा? What will be the charge of up cork? Plus 2 over 3e. Simple. All clear? Any ambiguities?